Hello, this is Charalampos Georgiadis, and I'll be showing you how my code works. So to begin with, this is the display that welcomes the player, and this is the input for the rules. And if they type in 1, then it will actually show this, and if they don't, it will just skip past it, so the rules won't be showed. Then for the input for both the color, the shape, and the wall color, they all work roughly the same way of how ask the input, and it says if they're not any of the correct numbers that we want to see, aka for the color, character color, it's 1 for blue, 2 for red, 3 for random. If it's not 1, 2, or 3, then it will say it's an invalid choice, you can't do it, and it will run through the same input until you get 1, 2, or 3. And then if it's 1, it will display color is actually blue, color is red, and color is random. And here, this will just set it as variable so it can be used later. Same thing with the shape, works the same exact way, and same thing with the wall color. Now, these are the starting variables. So again, we can see the current plot, the key plot, which is generated with a random integer from 1 through 8, plus 1, so it doesn't land in the first one. Found key, how it's 0, so it shows like it's false now, the key has not been found, and the moves which start at 0. Now here is how the character's positions gets generated, and this shows if whichever current plot it's at. So like if it's 1, then the x position is 1, the y position is 5. So 1, 5. If it's 3, then it's 5, 5, and if so on and so forth with the different positions. Now here is how when it starts actually like setting the shapes and the parameters for the plots. So it goes from 0 to 6, so they can actually fit the borders that were given to us in the document. So you can build this wall, for example, and the other walls that you will see when I play the game in the end. And then here we have that if the key, like if the random I variable, which is going through, where was it, 1 through 9, if it equals the same one as the key plot that was generated before, and the key is still not found yet, so just in the beginning, just a random generator, then the key position is generated from same thing as the character. So if it's 1, which it won't be 1, would be 1, 5, then it would be 3, 5, like 3, 5, and all that. So on and so forth. Pretty self-explanatory. Here's how it plots the key position, and this is it plotting the character position. Sorry about that. With the shape variable from before, the color variable from before, and all that. And here's how it fills it with black, just so it can restart. All the rest ones too. So this one this shows once the key is found, and that's if the current plot, if you're on like 3, for example, and the key plot is also 3, and the found key is 0, so you still have not found the key, then it turns the found key to 1. And then displays you found the key and escape to be fully free. And once the current plot, once you go back to the first one, and the found key is 1, so once you actually found the key, then it breaks, and it just goes through the animation, which I'll go and show in the end. This is the actual directions, how it asks for the directions. And I put this one because without it, the north one was just right past it, and it looked like right after this one, and it looked weird, so I didn't like that one. But we have valid moves equals 0 because if you are in current, like if you're on plots for 1, 2, and 3, and you're trying to move north, it might count that as a move, but with the valid move equals 0, and then nothing changing there, then it's not going to count it as an actual move. Because, 1, 2, and 3, you can't move north because not allowed. It's a barrier. Now, if it's not in any of those plots, the valid move equals 1, and then that is transferred here, like that is here. And then because it's 1, it adds 1 to the move, and goes through the loop until however many tries you get it. And now for here, this is where you get the animation for the leaving and the entering, and you use the lint space for the X position, so you can see like traveling to the X and all that stuff, and the Y position. Now here, this shows that if it is the next plot, same thing with this. So we backtrack a little bit. The next plot is found by using the current plot, and then, for example, if you want to move north, subtracting 3. So if you're here, you want to move north, it's 1, 2, 3. Here, you want to move north, it's -1, -2, -3. And same thing with like, where is it? With south. right? North, south, east, west. It's adding 3, so you can do 1, 2, 3, and east and west is the same thing, just adding one and subtracting 1. So you can move to there or there, and that's how you can find the actual next positions. And with the next plots, you can actually use it to find if it equals this certain plots, it will equal the actual x's or the y's to know where to have the actual animation end and start, so it can move from here to here and so on and so forth. And how many steps in between. So it's 10 intervals in between. And that's how the animations get created. And then if it's anything else, then it's just invalid option. So you can just run through it again. Now, if it does equal 1, as said before, the move equals move plus 1, so it adds 1 to the move. And this is where the subplots actually get created as you're moving. And then here it fills it with the color right there. Same thing with all these. So this is pretty self-explanatory. And here's how it plots the character leaving. So bloop bloop bloop, leaving here, then entering that one. Now, for the actual current subplot, we have here holding off, and this is same code, similar code, and just more of the same one that it does a lot of different, like it's a lot of the same stuff, just same thing with the key position and all that. Now, for the actual animation that plays in the end, we have the loop going from 2 through 9, so the first one doesn't change, and then we generate random values for red, green, and blue, and then that's used for the actual fill colors for each one from 2 through 9, with a random color created from the values of RGB that were generated for each loop that was going through here. And that's basically it. Let me run it one time. So let's see the code. Let's do random, let's do circle, and let's do green. Okay. Let's move east. They're moving east, south, south, west. There's the key. Let's move west, north, and I'll move east again. Oop. East again, so then we can actually see all the plots. And then back here, then we got back here. And there we go. There's the animation that plays, and that is my code. Thank you very much.